I'm Tom, and in this video I just want to quickly take you through a little project I've been working on for the past month or so, and that's a radiator monitoring system. Now, the system consists of two parts. The first one are these radiator monitoring sensors. So these connect to the tails of the radiator, and they send that data via Bluetooth over a mesh. And the second part is what I call the bridge, and this essentially takes all the data from each of the radiators and sends it via MQTT onto my network for storage. Now, I hear you ask, why would you want to build a radiator monitoring system? And the answer to that is twofold. Firstly, I'm really curious about the performance of the radiators in my house. When the heating system was installed 2.5 years ago, there was no design done, there was no heat loss calculations done. The 10 radiators were essentially hung and connected to a huge boiler. So I've always kind of wondered about how well that system performs as a whole. Now, I run a low flow temperature on my boiler of 45 degrees, and I really wanted a way to monitor what each radiator was doing. So as I started to tinker with the boiler, adjusting pump settings and flow temperatures and things like that, I wanted to be able to objectively capture how well each radiator was doing, so that I could then compare and contrast the behavior as I make those changes. Secondly, I had the idea that I could use the data gathered from each radiator to help me balance the system. Now, I've got several radiators in my house that appear colder to the touch than other radiators, especially the ones at the back of the house upstairs. And I know you can balance these, manually, but I had this idea that I could take all of the data being gathered from all of the radiators and essentially devise a small program that would do things like capture the order that the radiators are heating up in, and then it would allow me to see the results of each change that I make. So as I tweak a lock shield or I close a lock shield, I'm able to then see what happens the rest of the radiators as a whole, as opposed to just moving radiator to radiator. I've almost got that kind of program working, but it's not really ready yet. There's a few little bugs in it, but I will show you what that looks like as part of this video. So now you know the why, and I'd like to now take you through the how. So I want to show you the little sensors that I've built and how they're installed. Now currently that's a mix of breadboard units and some kind of strip board units, and then I've got two custom PCB units that I've had made, and I've assembled those. And once I've shown you the hardware and how it's crudely installed around my house, I'll then take you quickly through the software. So that's broken into two parts. So I've got a monitoring section and the aforementioned balancing section. I also have, using MQTT, I've also set up logging of all that data into an InfluxDB instance. So I've been able to track the behavior of my monitors. I've been able to track the behavior of my radiators over the past kind of 2 weeks since I've installed the sensors. So I'll give you an idea of what that data looks like, and I can show you then how the actual raw data does confirm all my suspicions about the behavior of the radiators upstairs. And that's it. So without further ado, let me take you around the house and I'll show you the various sensors that I've installed. So we'll start in the master bedroom, and I've got one of the strip board sensors connected here. So this is the same, it's just been mounted on a piece of strip board, and it's currently powered by a 3.7 volt battery, and that's just connected to the tails of the radiator on either side. This one's got a little switch for turning it on and off. Jumping over to my kids' bedroom, I've got another sensor there. This one is mounted on a small PCB, and again that's connected to the tails, but in this instance I've been able to run power to it. So that's being powered just by a wall adapter. It's USB. This is the back bedroom, and you can see there's another PCB based one, and that's connected again to a wall powered USB adapter. This is the bone of contention in the house because of where this is. So I've got one of my custom PCB boards there, and that's connected to the landing radiator. And then over here I've got a PCB one, and that runs into the bathroom, and that's connected to the tails of the towel rail. You might be able to see that there. So there's one on each side of that. This one I've got to get boxed up because it's a trip hazard really, but anyway. Then if we go down the stairs, ignore that masking tape, then we've got another PCB based one, and that's sitting on this big radiator in the hallway. Tucked in behind the couch is another one connected to the sitting room. That's another PCB based one, and that's powered from the wall, again like the others. Under the living room, which is quite dark, you can see there's another, and that's a breadboard based one, and that's just sitting under the radiator, and again it's plugged in at the wall. And then coming to the end, this is the one connected to the radiator in the hallway, or in the kitchen, sorry, and that's another strip board based one that's plugged in up there. Now I do have underfloor heating in here, but as we had this radiator already, we left it in place. And lastly is the one in my office. My office is an absolute bomb site, so I'm not going to show you that one, but it's the one I held up earlier, and it's a PCB based one, powered by a battery again. I've got two running on battery because I just really want to see what sort of battery life I get from the large batteries. It's currently about a week, which I think is pretty good given that the sensors are updating every 5 seconds. I've got them going that frequently for the purposes of the balancing project that I'm trying to get to work. So I'd like kind of like it to be real time, or as near real time as possible. So that's the hardware. I'd like to take you through the software now. Alright, so here we are logged into the bridge. So the bridge is an ESP32-C3, and that supports Bluetooth and Wi-Fi, and it's currently connected to my local Wi-Fi, and inside it's running its own little web server, and it's gathering the data from all of the different sensors. So I've got 10 of those around the house. Each one has a number encoded in it, so they just run 1 to 10. That just makes it easy to identify which is which. And then you can name the sensor. So once you've installed the sensors across your radiators, you then basically have to figure out which is which. So if you do it kind of one at a time, you can add the sensor, turn it on, it'll get picked up, and then you can give it a name. So I've got my 10 here. That ranges from the bathroom, office, living room. It's all the sensors I just showed you. And the sensors themselves use something called a Bluetooth mesh. So a mesh means that each sensor can talk to the other sensor. Effectively means that I can spread the coverage across the entire house quite well just by having each sensor within a couple of meters of each other. So I've got the bridge here upstairs, sitting on my desk, and that's able to reliably communicate to the kitchen, which would be probably the furthest radiator from here, as that hops through, I think it hops through the living room and then probably the hallway and up the stairs, whatever. So it can make its way anywhere across the house to me. In terms of the data then, The flow and return are actually, they're obviously logged, and then we compute the mean value of the radiator, which is just adding these together and dividing by 2. And then I aggregate that data up at the top to kind of give me an overall idea of what the mean temperatures of the radiators are. Now the radiators have been off, they've been off pretty much all day, so the rads have cooled down, and we're looking at a mean temperature of around 13. There's an updated flag here. This doesn't quite work yet, but the idea there will be it'll tell you when the sensor was last seen. So if you do have any connectivity problems, that will tell you. At the moment, this is just saying that the bridge was rebooted 2 hours ago, so everything is 2 hours old. We can then open each one, and we've got the ability to rename the radiator if needs be. But more importantly, we've got an option here to reverse the flow and return sensors. I've added that in because when I was attaching them, I don't know which is which. In terms of I know which sensor is which, or which thermistor is which, but I don't know which tail is which on the radiator. So rather than having to try and figure this out, I just made it something that I could swap them around. So if I notice that, like in this instance, the return here looks a bit bigger than the flow, if it's quite obviously different, then I can flick that switch, and that will swap the readings around, so they're logged in the right place. Another function of the bridge is to connect to my MQTT server that I'm running in the house. So I've got MQTT Explorer open, and this essentially is capturing the bridge is basically sending this data via MQTT. So if I were to open, let's say we just open the bathroom, I can expand that at the side. So this is sends quite a lot of data. So it'll send the type, that's just to do with balancing, so don't worry about that for now. Then it sends the number and the current readings. It'll say whether it's calibrated and warming. Again, these settings are for the balancing, the deltas for the balancing. And then it's got a room name. So what I've been able to do with that, because that's coming in from all my radiators, is if I jump back to my browser and I jump over to InfluxDB and I sign in, and I go to the Data Explorer. Now I've set up a telegraph instance, and that's connecting to MQTT, and it's gathering that data from the bridge, and it's parsing it out into something that can go into Influx, and it's logging into a bucket called test at the moment because I'm not very imaginative with the names. And if we look in here, it's really struggling with this small screen. I've got measurement, so I should be able to find. I'm just going to have to make the window a bit bigger. You may not be able to see that now, but there's a degrees C option, which I've picked. And then I can essentially pick the mean temperature reading. And then if I just say past 6 hours and I submit that. Now, so you can hopefully see that. It's not particularly big, but you can very easily see that around this time in the morning, this was at 11 o'clock, I think, today, the heating came on and the mean temperature of the radiators sort of rocketed up. And this kind of information now does sort of confirm my suspicions. So you can see that the radiators don't evenly heat. There's a couple of laggards here. So we've got a cluster up at the top, and they're all heating to sort of 35, 36. And then the master bedroom, which is one of the coldest radiators in the house, has only reached a mean temperature of 29.8. So this is showing me, or it's confirming rather, my suspicions about how well the radiators are performing. So the heating was obviously on for whatever that is, maybe half an hour, and then you can see the temperature starts to drop off as the radiators cool down. This little anomaly here will be the office radiator when I disconnected it to show you to hold it up in front of the webcam. So that went a bit wobbly, but that's sort of settled down now, and that's back to a mean temperature of about 14. Now, we can also then look at the return temperatures. And again, this paints quite an interesting picture because we can see that some of the return temperatures, again, are quite low. So that I'm still kind of getting to grips with what all of this means in terms of radiators. But initially, or currently, I believe that's to do with not enough flow coming into the radiator. So there's just not enough heat entering the radiator. So it's got quite a low return temperature. We've got a couple of quite low, like the back bedroom there, that actually ends up with a return temperature of only 27. And again, we've got some wobbles, but it really does confirm what's going on in terms of the radiators. So that kind of covers the monitoring part and how I'm using that data coming in. And I'd like to now, if I may, briefly show you what I'm trying to do with the monitoring. Sorry, not with the monitoring, I'm just showing you that, but what I'm trying to do with the balancing. So the balancing is a bit more interesting, and what I've been trying to do is break the balancing down into the two most common steps that I find when I look at guides on how to balance your radiators. So looking at the monitoring, it's clear that my radiators aren't balanced. Some are much colder than others. I won't go into whether or not all the radiators should be at different temperatures based on the heat losses of the rooms at this stage. That this is too early for me in the process to start getting into that kind of level of detail. But what I just want to quickly show you is how this is going to behave, or how I'm hoping that this will behave. So I'll jump into Home Assistant just so I can get a grab of my heating, and I'll hop back. So essentially what we want to do, or what this part of the application will do, is it'll guide you through the process of trying to achieve an even, what's called delta T, or difference in temperature across each radiator. So the theory is that you should have a consistent drop in temperature from the water going into the radiator to the water coming out of the radiator, and that should be roughly the same across all the rads in your system, which means the heat is being evenly distributed. It's a lot more nuanced than that, but I'm sticking with the kind of crude model for now till I get something up and running. So we start with the start balancing, and what this will now do is it'll basically grab the current temperature, the current mean temperature of all the radiators. So we kind of have a starting point. So it's done that now, and it's telling me to turn my heating on. So I'll jump into Home Assistant, and I will flick this switch. And this should now turn my boiler on and start circulating hot water. There's always a pregnant pause here as the boiler sort of thinks about what it's going to do. So if I let that kind of decide, so what should happen now is the system will be now monitoring the mean temperatures across the rads. Well, actually it's monitoring the flow temperatures or the flow pipe tail on the rads, and it will check for changes in that. So once it's changed by, I think, half a degree, it'll assume that the radiator is heating up. So you can see that now we've got our first one. The hallway is literally the closest radiator to the boiler. So that is always kind of expected. Sitting room is next in line. we've got the office heating up now. So the office is upstairs, but again, on that sort of branch, it's the closest radiator. And then we typically should get either the landing or the bathroom to go next. So we've got the bathroom to go. So again, that's another branch off the main loops. And these three now are the furthest rads. So we can see the delta T's is climbing across the rads, and it's working out the order of heating. And with any luck, the kitchen and back bedroom will start to warm up too. We now have all the radiators heating. Again, the order is what I would have expected, knowing what I know about the plumbing and how things are laid out. And this is the part where I've kind of gotten to. So it's now essentially telling me, based on the delta T across each of the radiators, what I need to do. So I've configured it for a delta T of 5 degrees. I picked 5 degrees because that's a figure I keep hearing for a 45 degree flow. And yeah, so what it'll do is if you're within sort of half degree, so if you're over 4.5 or under 5.5, it'll give you this little green tick. Otherwise, it will tell you that you need to close the lock shield down, or in the case of the kitchen, open the lock shield up. Now at the moment, all the lock shields are wide open. They have been since the system was put in, I think. And you're getting some quite large delta T's. So that's where I've gotten to. The next phase will be to essentially hold your hand, and as you adjust each one, let that go green, and then it will point you at the next one. So you will then walk around, make the adjustment, wait, make another adjustment, and wait, and see how that kind of affects the system overall, with the aim of trying to close down the delta T's. Again, this is all more nuanced than I'm letting on, but this again is the crude way to balance your radiators. You'll find this online. They typically will say, yeah, just put some temperature probes either side, and once it gets to like 12 degrees, move on to the next radiator in the order that they warm up. This, I hope, is an improvement, or it appears to be an improvement, because it will gather the order for you. You're not relying on running around the house, putting your hand on the radiator to see if it's getting hot water. So at least you can do this from a central location, and then as it's being monitored, you can make an adjustment, and you can kind of wait a few minutes, because if radiators are too hot, or they will take time to cool down. So you can kind of run this and check it sort of every 10 minutes or 15 minutes if you're doing this in the comfort of your own home. So that's where I'm at. I'll just stop the balancing, and then we're back to normal, and we can jump back to the monitoring, and you can see those mean temperatures have climbed up. So there you have it, my radiator monitoring system. Very much a work in progress, but slowly getting there. I'll definitely do another video once I've got the balancing flow working, so hopefully that should be interesting. If you would like to share your thoughts or ask me any questions, please use the comments. If you've enjoyed this video, please remember to like and subscribe. And that's it. I'm Tom, and thanks for watching.